All right, so we're going to break down into some different methods that you might have to do when you're finding the area between curves. We're going to do these first 3 in this set of videos. We'll kind of practice that, and then we'll add this final method for the next class and do some more practice with this final method added in. All right, so now we're going to look at 3 different possibilities that could happen when you're finding the areas between curves. All right, our general strategy for finding the area between curves, you have to find the start and end of the area. All right, it's basically always going to be when the 2 functions intersect each other, and that's they tell you to use a specific ending point. I identify which function is above the other. If you already have a kind of picture in your head or a graph, you can just basically look at the graph and figure out which one is above the other, because we saw subtraction is going to depend on whichever one's on top. You set up your integral using the bounds you found from step 1 and the kind of function on the top first that you found in step 2. And then once you have your integral set up, that's just like all the substitution problems and stuff we've done. You just calculate your final answer as an antiderivative and plugging numbers in. All right, so we're going to find the area between the curves f of x equals 9 minus x over 2 squared and g of x equals 6 minus x. All right, so the first thing we're going to do in these problems is draw a picture, because we need to visualize what's happening, which function is most likely going to be on the top, and so on. And again, I'm just going to draw a really rough sketch. This graph, f of x, is a quadratic function because of the x squared. And I have the minus in front of the x squared part, so it's going to be a downward facing parabola, and it's going to start at 9. So it's going to look something like this. And it doesn't have to be exact, I'm just getting the basic idea of what the picture looks like. 6 minus x is a line, the y-intercept is 6, and the slope is -1, so it's going to look something like that. And I'm trying to find the area between these 2 curves, so the area I'm trying to find is this section. All right, so that's the basic idea. I can graph these 2 functions, kind of visualize what's happening, and see the area I'm trying to find. All right, so now if we go through our strategy, the first thing to do is figure out where this starts. All right, so I can use that as my starting x value, and where this ends. And I use that as my ending x value. All right, when do these 2 things happen? It's when my functions cross each other, which if functions are crossing each other, it just means that they are equal to each other. So I'm going to set these 2 equations equal. First of all, I'm going to square this. I'm going to, let's subtract 9 first. And then normally when we're solving a quadratic equation when there's x squared, I want to get everything on one side. So I guess I should just subtract this 6 and subtracting 9. So I'm going to get plus x plus 3 equals 0. And then I'm going to multiply everything by 4 to get rid of that fraction. I actually multiply everything by -4 to turn the x squared positive. So x squared positive. It's going to be -4x minus 12 equals 0. And this does factor as x minus 6 times x plus 2. Let's see, -6 times 2 is -12. -6 plus 2 is, yep, so that's factors like that. And that gives me the answers 6 and -2. All right, so that's a little bit of side work just to figure out that this value here is -2, and that value there is 6. All right, so putting all that together, now I can make my integral. It's going to be from the area from -2 to 6. All right, the top function goes first, so in my graph, the top function is the red one, so 9, and I'm just going to automatically rewrite this as x squared over 4. All right, then I'll subtract the g of x function, 6 minus x. So I take my top function, the red one, subtract my bottom function, the blue one, and do it over the appropriate bounds, and that's my integral for the area between the curves. So to do this, do a little bit of simplifying. Plus x plus 3. Now I can do the antiderivative. It's going to be add 1 to the power, divide by the new power. I add 1 to the power, divide by the new power, and I said I put an x after the 3. All right, so that's my antiderivative. I'm going to evaluate that from -2 to 6. All right, so now just to keep the video short, I'm going to pause the recording, just kind of work out the calculation for that. Because again, it's just plugging in numbers, but I think it's useful to see the final answer. All right, so I quickly worked out the final answer in the bottom here. So I plug in 6 into this antiderivative I found. I subtract when I plug in -2 into the antiderivative, and it's just some simplifying, combining terms, and I got this answer at the end. I have no guarantee that that's the final correct answer, but all the steps make sense. We figure out the endpoints where these two things intersect. We have to do that by setting the equations equal to each other. Then we can set up our integral. The integral is from -2 to 6. Those are the places where they intersect. Take the top function, the red one, which is the quadratic one. Subtract the bottom function, the blue one, which is the line. I can do some simplifying before I take the antiderivative, just make my life a little bit simpler. And then once I have the antiderivative, I just plug in some numbers and simplify. All right, so that's how you would find the area between two curves. We're just going to do this one example in this video because you can see it took a little bit of time, and we're going to do practice in class. And plus, when we're doing the other methods, we kind of have to do the same thing again, just in slightly different ways or adding slightly some more steps. All right, so we'll see more practice. But for this video, this is our example of how to find the area between these two curves.